This video is about geometry, rotating points or figures, rotating, if you have a triangle, you're rotating 3 points about some point. Sometimes it's the origin that you have to rotate about, sometimes it's another point. And they have rotations of 90 degrees counterclockwise, 180 degrees counterclockwise, 270 counterclockwise. If it doesn't specify which direction, it's counterclockwise. Counterclockwise is positive angles. So if it tells you clockwise, well, think about this. 90 degrees clockwise is 270 degrees counterclockwise. So this would also be 270 clockwise. 90 degrees counterclockwise, rather. I think I said clockwise, maybe. 90 degrees counterclockwise is 270 clockwise. 180 degrees, it's the same, clockwise or counterclockwise. Counterclockwise there, clockwise there. And 270 counterclockwise is like this, and clockwise would be the same as 90. So this is 90 clockwise. So that's why a lot of times in class you'll only study the counterclockwise one. So again, if it doesn't say what it is, it's counterclockwise because those are positive angles. But if it does, these are the comparisons. 90 counterclockwise is 270 clockwise. 180 counterclockwise and 180 clockwise are the same. 270 counterclockwise is the same as 90 clockwise. The other thing, sometimes there'll be a question like this where it says, here's a point. This is the reflection. This is the rotation of a point, and that rotation has the coordinates 7 minus 2. And then it'll ask in some way, what was the original point? What was point P? What was point P? What was point P on these different rotations? Hold on, I'm going to make a little bit more room here. So to get to point P, I just have to ask myself, I said, I'm at, if it said, here's P prime, here's the rotation of P prime 7, negative 2, what was the original point P after a 90-degree rotation? Well, I have to turn negative yx back to x, y. So this is negative y, this is x, so I have to turn it to x, negative 2, and then I change the sign of y, negative 7, because it's negative y. So the original point was negative 2, negative 7. Negative 2 is x, negative 7 is y. And to rotate it 90 degrees counterclockwise, I get negative y, which is 7, and x, which is negative 2. So just go backwards. Let's say it was the rotated point, P prime is 7, negative 2. What would the original point P have been if it had been rotated 180 degrees, clockwise or counterclockwise? So I got to turn negative xy into xy. In other words, I just changed the sign of both back to what they were before. Negative 7 and negative and 2. So I just changed the sign of both. Negative 7, negative 2 became negative 7 or positive 7 and negative 2. What if it said, here's the rotated point, and it was rotated 270 degrees counterclockwise or 90 degrees clockwise? Well, the point I'm given with P prime is this, and I have to turn it back to x, y. So from where I am now, the x changes sign, so that goes to 2, and then the y stays the same, 7. So 2, 7 became y, 7, and then negative x, negative 2. Or if I go backwards, 7, negative 2 becomes 2, 7. So you can always say, what if I start with the rotated point and then go back? Now, another thing it might ask is to rotate about a different point, a point that's not the origin. All of these above here are rotations about the origin. How do I rotate about a point that's not the origin? Well, step 1, subtract point of rotation from the point. Step 2, rotate as normal. Do your rotation. Step 3, add the point of rotation back to this result. So I'll give an example. And it could be done with 1 point. It could be done with 100-sided figures, with 100 points. It's all the same. Let's say I have a point. The point is 6 minus 4. And I want to rotate, I would say around, but they always say about. Rotate about a point, rotate about the point 4 minus 4. So step 1, subtract the point of rotation. 6 minus 4 is 2. Negative 4 minus negative 4 is negative 4 plus 4 is 0. So now I'm going to do, let's say I wanted to rotate this about the 90 degrees. I want to rotate it 90 degrees. Well, 90 degrees, xy becomes negative yx. So this is xy. I get negative yx, so it's 0, 2. And then add the point of rotation back to it. So in other words, put it back in the frame of reference that it started with. So I'm going to add 4, negative 4. 0 plus 4 is 4. 2 plus negative 4 is 2 minus 4, which is negative 2. So that's P prime. If this was P, then this is P prime. And I will show it. I'm rotating 6, negative 4, about 4, negative 4. I'll show it visually here. I want to rotate 6, comma, negative 4 about the point 4, negative 4. And I claim the result is 4, negative 2. Whoops, 4, negative 2. And you can see that here's the point I'm rotating about. And sure enough, if I rotate it 90 degrees, there's that 90-degree angle between the two of them around that point. So again, step 1, and you have to do, if it's a multi-sided figure with multiple vertices, you have to do this 3 times for every vertex. If it's a triangle, if it's 100 vertices, you have to do it 100 times. Step 1, subtract the point of rotation, subtract the x value from the x value, subtract the y value from the y value. Then do the rotation. If it's 90 degrees, then xy becomes negative yx. If it's 180, xy becomes negative x, negative y. If it's 270, xy becomes y, negative x. And then add the point of rotation back. I'll do one more. Let's say my point is negative 2, 7, and I want to rotate it 270 degrees about the point, I'll call it the point of rotation is negative 4, 17. I'll go to some crazy point. All right, so remember, step 1, subtract the point of rotation. Negative 2 minus negative 4 is negative 2 plus 4 is 2. And then 7 minus 17 is negative 10. Now I'll do my rotation, 270, and it didn't tell me a direction, so it's counterclockwise. 270, xy becomes y, negative x. So y, negative 10, negative x, negative 2. I change the sign of the x. And then the last thing I have to do is add the point of rotation back. I guess I really don't need more room. Negative 10 plus negative 4 is negative 14. Negative 2 plus 17 is 15. And so there's P prime, which would be a rotation of 270 degrees. Doesn't say direction, so counterclockwise. Around a point, negative 4, 17 would be negative 14, 15. So let me double check it. Negative 2, 7. I will plot these just to show it. Negative 2, 7. And I want to go around this point, negative 4, 17. Neg 4, 17. And I'm going to label that one because that's the point of rotation. So there's the point I'm rotating it about. So it's 90 degrees. It's going to be somewhere around here. I'm pointing with my mouse. You can maybe see the mouse pointer there. And that my claim is that it becomes negative 14, 15. Oh. That was a clock. Oh, this wasn't 90. This is 270. Okay. So that's 90, 180, 270. Yeah, so that's what it would look like. It would look like 90 degrees clockwise. 90 degrees clockwise is the same as 270 degrees counterclockwise. So there it is. So I can kind of visualize it. When I'm doing my homework, I can visualize it using something like Desmos just to see that the thing was right. So in other words, this is my point of rotation. I'm just approximating. This is the point. This would be 180, and then this would be 270 right about there. So that's what it looks like. And it's, when it doesn't give direction, counterclockwise. And that's what I got there. So this is, let me show this, just in case you don't see it. This is P prime. And this point is P. And you can see that it rotated it 270 degrees. So there it is. That's how to go from the rotated point back to the original point, and also how to rotate about a point that is not the origin.